Okay, here's your masked Avenger teacher, Mr. Samuelus. Don't have my own room, so I'm in a common area, so some teachers may walk in during this lesson. But anyway, I'll shut my face off wearing this thing. Hopefully you can still hear me very clear. Okay, as promised, I'm going to do this video on changing the period and amplitude, and it's just going to be pretty direct. So after your extrapolation of finding all these points to get the sine and cosine graph, and good little chapter 3 review on doing that trig. Here's what we got for sine and cosine, and I highlighted the components. What you got to remember about sine is two bowls, as far as when we graph these, and then the cosine kid. Anyone that's watched the Karate Kid. That's the crane, is what cosine looks like. And I went ahead and drew two periods. So pause the video and maybe show the left side of the origin that we have a cut and paste. This is why we call sine and cosine to be periodic, because it just is repetitive, a repetitive wave. And then one thing that I did mention with one of the classes is, hey, look at just this part of the cosine curve. Hey, what does that look like? And the answer is it looks like a sine curve. Just because sine and cosine, which are both called sinusoidals, let's write that word down. Sine, so that's a U. We have no time to make any corrections here. I want to keep this short. It's because they are the exact same graph but shifted. All right, but I want you to think of sine as two bowls, cosine kid for cosine. We said the period. Now this is where we're going to make some changes, but I'll put this up here, and I did put domain and range. Let's look at that. There you go. And I think you should understand that the range is only from -1 to 1, because that's as high and low as each graph goes. In the domain, we can plug in anything and cosine or sine it. So it's all real numbers. But things that we said, because this is based off of what's going to change today. The period is that x-axis distance where the graph remains unique. And then after that period, it starts repeating itself. So that's why the period for both of these is 2 pi. Oh, and the amplitude, I don't know what that sound was, is 1, which is half the y-axis distance. I'm just going to put half y-axis, because this covers a distance of 2 from -1 to 1. But just keep that in mind for later complicated questions. Now, what we're going to do is make new graphs. And this is when the amplitude and period change. Amp, period, change. And I'm just be very direct with it. Back in the past, I've derived it and showed you why through examples. And I don't even know how far that really went anyway. So I think we're okay with just saying your equation is going to look like this now, where we're going to insert some new numbers. B of x. Notice up here in both of these equations, it's 1 times sine 1x. 1 times cosine of 1x, right? And we don't ever write the ones. That's the parent function. This is what the parent function looks like. Now it's time to make babies. So A is easy. A is the new amplitude value. Whoops, tried to draw an A and an M at the same time. You can think of amplitude very simply as stretch, shrink. Stretch. Now I'm just going to put SHR for shrink, because that's really what it does. It just stretches or shrinks. It's the graph. I don't know what I was going to say there. And then the period. Now this is where you got to lock this in. The period change. Once we get this B value in here, the new period for the graph will be 2 pi, because that's the parent period. And then because mathematically that B being where it's at, the new period for the babies will be 2 pi over B. All right. And then what you will see is all that changes is, let's pick the cosine graph. Your graph is going to look very similar, but then it will end at whatever 2 pi over B is, and then you will have to find what these new values here are. which is just a fractional challenge. As a fatter math, you could divide all those by b, and then that would actually take care of the job. But I have another way that I hope you acquiesce to, or whatever. I don't know if that's the right word, but trying to struggle with words today and early in the morning here. Okay, so here's our first graph. Kept it simple. Y equals 3 sine. I don't see anything there, so that's just a 1x. So that means the amplitude is 3. And by the way, amplitude's always positive. Probably don't want to be jerky about that this year and say, what's the amplitude? And I have a negative in front, and then you say A is -3. It's technically wrong. Amplitude is always expressed as a positive, and so is actually period. So here's period. It's 2 pi over, well, I just have a 1 there, so it's 2 pi. So I'm going to go right to the graph and graph one cycle. That just means one iteration of sine. So what do I put right here? I put right here whatever the period is. Now I tried to do this in class to get you to understand, the key components here. Take half of that and then take half of that. And that's how we're going to find when this changes. Now notice this is the same period values for the parent functions, pi over 2 pi, 3 pi over 2, 2 pi. Okay, these are the key components, but listen to what I say. 1 pi over 2, 2 pi over 2, 4 pi over 2. Oh, so this must be 3 pi over 2. This is how I'm always going to break down these x-axis values when we're graphing with new periods. Just stick with me. Knowing this is sine, this starts at 0, 0, hits its high point, which is now 3 instead of 1. And that happens here, and then back to 0, bull, and then low point, and then back to 0, bull. Then I prefer some arrows that this continues this pattern. Let's move on. Oh no! What does that negative mean on the inside? And I still don't have a number to change the period. But what I do have is what's called a y-axis reflection. You must remember, still the same. Negatives on the outside, flip it over the x-axis. Negatives on the inside of the function, flip it over the y-axis. So we're still going to go ahead and graph. That's awfully large. I'll put this here, 2 pi. I still have a period of, so amplitude's 4. Sorry to go over that fast. Period equals 2 pi. You never really say the period's negative, so just say 2 pi over 1. That negative is the y-axis reflection that we must must show in our graph. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2. Well, it's the same one as the last one. There was no change in the period. So it's the same graph as we had the last one, except two differences. Number one, the high and low points. And number two, let's think about a y-axis reflection. Let's look at the parent. When I take this and I use this as like the swing here, then this swings over to this side, and actually we have this graph. So it does actually kind of look like an x-axis reflection as well. Think about this flipping over to this side. This lower bowl flips over here. So that is what that graph is going to look like. So knowing what the parent looks like so that you know what our new picture will look like. Again, it's a sine, so it starts at 0, 0, hits its low, now why does it hit its low? Because of that swing over the y-axis. All right, so we do have those things that all functions have as well in cosine and sine. The big thing here is getting these x-axis values marked, the y-axis values marked, and then watching out for reflections. All right, let's change the period here. And I'm going to graph this over a 2-period interval because it's not a big deal. Kind of said to the other cat teachers, I'm just going to stick to 1 period. On the worksheet, I believe it's 1 period, so you should be fine there. Ooh, got to hurry up. I do want to make this fast. Okay, so first of all, the amplitude is it's 2, so just too high, too low. The period is now changed. Oh, and the only reason you're going to hate this is because you're fractionally challenged. Again, I'm trying to do some things to tell you about this fractional stuff so you get better at fractions, because this is the only way you're going to survive. Okay, so what do I put here? That's where the sine curve ends. And I did another sine. Finally, a cosine in the next picture. So, okay, so if you need to do the work off to the side, please do, and I will show that. What's this right here? Well, it's halfway. So what's half of 2 pi over 3? So it always makes me infinitely sad, people not being able to cross cancel. And then this is half of what I just found there, because I'm cutting this into fourths. So this is the fast, quick way of getting your new critical values. And I'm not writing that over there, I'm writing that over there. Pi over 6. Okay, so half of pi over 3, multiply 2 times 3. That's how you multiply fractions. And then what's this? This is the 3/4 way. So you could either take 3/4 of 2 pi over 3 and then do your math on that, or 1 pi over 6, 2 pi over 6, pen is infinitely annoying, 3 pi over 6? Is this 4 pi over 6? See, that's the quarter value. I'm just adding pi over 6, pi over 6, pi over 6, pi over 6. And then whether you do it this way, the 3's cancel, and the 2 cancels with the 4, or you reduce 3 pi over 6, this is pi over 2. So all that happens when the period change with this b value here, you use the formula to change the period, 2 pi over whatever b is, and then you cut it into fourths. All right, so re-look at that, or else I actually have a couple more examples of this. Okay, so what do I do about sine? Well, I do have too high, too low. And sine starts at 0, 0, and we get the bowls. There is no flip. So here's the high point. Now it happens at pi over 6. That's the difference. And then 0, and then low point, and then 0. Bowl, bowl. Now this is why 2 periods ain't no thing, because all it is on the other side is cut and paste these, but they're negative. So once I get that side, I like cutting in halves and then quarters, so then I can write those. So it's kind of silly, but I want you to know that this is periodic, meaning here's the next sine curve, a repetitive sine curve. Now this is the low point. Ooh, I destroyed that -2. And the common error people do is they make this go up again. Nope, it flows. Now it's a downwards bowl and then an upwards bowl. And then I see 2 sine curves. Here's one complete sine curve. Here's a second. That's what 2 cycles mean. Okay, all right. 2 more. Ooh, 8:20 and the bell's about to ring in about 8 minutes. So I gotta fly. The amplitude is not -5, but what this is an x-axis reflection. So we got to graph an upside down cosine. Hey, here's our first cosine with the period changed. Now you're going to like this one. I really hope you're good with fractions, because dividing by 1/4 is the same thing as multiplying by 4. Now, I wish I had time to discover how this graph is so completely different than the other one. We should graph the parent, graph the last 2 examples together, and see how different they are together on the same coordinate plane. For instance, this one's way higher, and it ends at 8 pi. Actually, I could kind of bring it up with the last one. And then, okay, we got to cut this into fourths. That's easy. Cut it in half first. Cut it in half again. This is even fractions. 2 pi, 4 pi, 8 pi. You're supposed to say 6 pi. Oh, and then since he wants 2 cycles, and don't be I had somebody graph 2 cycles worth, graph 2 periods, or graph 2 cycles. And I had a clown one year draw 2 cycles, two bicycles on the coordinate plane. All right, that was great. F triple minus. I had no time for that joke. What are you doing, Mr. Samuel? -8, and nobody laughs anyway, so why even try? 8 pi, 4 pi. 2 pi. How can anyone laugh when nobody's here? I don't know. Love having to write my pen 6 times for something to actually write. It's fun. Okay, now let's be careful. 5 to negative 5. And think about the cosine kid. Okay, so the cosine kid starts on the high point, goes to 0, then to the low point, but it's flipped over the x-axis. So it actually starts at the low point, hits 0, to the high point, 0, then the low point. Hiya, that is an upside down cosine kid. Okay, so that's the difference. Make sure you read, and notice how I flipped around. I didn't make that arrow go past that. So on and so forth. Okay, and then up and then down. Okay, and then just because of time, I don't have, I guess, a lot of time to put this graph into the same graph as this one. But you know what it is? It only goes, I guess I will, it only goes too high and too low. And 2 pi over 3 like ends right here. So if I were to put this graph compared to what this graph is, it'd be like this. There would be that sine curve. That's the comparison between this graph with the x-axis and y-axis values compared to this one. But you don't have to care about that. Your graphs will all look very similar. You just have to mark the axis correctly so that we know. All right. Last one. I have time for it. This is a fractional troublesome situation. Amplitude is 4, no reflections. Period is 2 pi over 7, and I picked this on purpose. Going to do 2 cycles worth because it ain't no thing. Chicken wing. No time, Mr. Samuels. Okay, what is half of 2 pi over 7? Pi over 7. I'm not writing it off to the side. What is half of pi over 7? Pi over 14. Get it figured out that when you take half of a fraction, you can multiply the denominator by 2. All right, and then 1 pi over 2, 14. 2 pi over 14, sorry. 1 pi over 14, 2 pi over 14, 3 pi over 14, 4 pi over 14. It's 4 pi over 14, 2 pi over 7. If you don't know how to reduce fractions, blah. So that's 3 pi over 14. Or this value is always 3/4 of the period. Feel free to write that math down because that's what I've done. I've cut this into fourths. All right, and then as if I have the time, 2 pi over 7, and then half, quarter, and I'll copy those values. It's really a cut and paste after if we're graphing 2 cycles, 2 periods worth. All right, and then it's over. All you have to know is what a cosine is. No flipping, no reflecting. So cosine start at the high point. That's 4. That's 3 times I tried to make that tick mark there. Love it. So there's our vertical stretch, our amplitude. And then there's the cosine kid points. So just don't forget what you have, cosine or sine, so that you get the correct graph at the end. Cosine kid, there's one cycle or one period. Here's a second cosine kid. Hoo-ah! And then watch the Karate Kid or Cobra Kai over the weekend, and then you'll know about the crane and why I call this the cosine kid. Nice end. All right.